Welcome all. So today we are going to discuss about hill climbing algorithm. So as the name suggests, it is an algorithm which is inspired from hill climbing process. And before going to this, we just discussed about the searching algorithms. So naturally, we have two types of searching algorithm. One is local searching algorithm, and another one is global searching algorithm. As the name suggests, this local searching algorithm mostly doesn't use this heuristic data, whereas global searching algorithm uses heuristic data. So we get into this hill climbing algorithms. A climbing algorithm is a local search algorithm which continuously moves in the direction of increasing values to find the peak of the mountain or best solution to the problem. As the name suggests, hill climbing is an process of climbing a hill in order to reach the peak of the hill. So when you reach the hill, you find another path to climb down. So naturally, this process is inspired from the hill climbing process, and this forms a local search algorithm. This and it terminates when it reaches the peak and value when no neighbor has high value. So naturally, if a person climbs a hill and reaches the peak and finds that the peak of the hill is at the place where he or she is standing. If he finds another hill which is another neighboring hill which is higher than the position, then he has to climb down and has to climb the other hill. So naturally, this comparison with the local climbing system will give a searching algorithm with a good solution. And the hill climbing algorithm is a technique which is used for optimizing mathematical problems. One of the one of the widely discussed example for hill climbing is traveling salesman problem, in which we need to minimize the distance traveled by the salesman. And this hill climbing algorithm is also called as greedy local search, as it is only looks its good immediate neighbor state and not beyond that. So naturally, we can find or we can compare between hills with the neighboring hills, which are nearer to them, and we can decide which hill is having a higher peak. So for that reason, this characteristics is inspired, and it forms a good solution for some of the mathematical problems. A node of hill climbing algorithm has two components, which are state and value. Hill climbing is mostly used when a good heuristic is available, and in this algorithm, we don't need to maintain or handle search trees or graphs, as it is only kept in single current state. So the main features of hill climbing algorithm is generate and test variant. This climbing algorithm is a variant of generate and test methods. This generate and test method produce feedback which helps to decide which direction to move in the search space. So naturally, greedy approach algorithm moves in a direction which have optimized cost values. And moreover, this hill climbing algorithm doesn't have any backtracking process. uh, and does not remember the previous state when it finds the other peak is high. So this is the state space diagram for a hill climbing algorithm. So objective function, and this is the state space, and this is the global max, and this is a local max. So when a person or when a hill is climbed and it compares with the local um, data, and if it is higher, then it updates its current position. It does not retract its position, and it just compare with the nearby nodes and move on. And if it does not forms any if it finds another peak is high, then it will move on. And if there is no traces of high um peak, then it forms a global max, and this global max has been the overall data, and this is our current state. So different regions in state space is local max. So local max is a state where which better than the neighbor state, but there is also another state which is higher than it. And global max is a best possible state of space landscape. It is highest value of objective function. Current state is nothing but the current present location of the agent, and flat local max is a landscape where a neighbor state of current state have the same values. And shoulder is a plateau region which has an uphill edge. So we have types of hill climbing algorithms: simple hill climbing, steepest ascent hill climbing, and stochastic hill climbing. So this we'll discuss in forthcoming chapters.